Hi, Year 11, this is Mr. Lim here, and this is our second video on calculations on moles and Avogadros number. So let's get into it. All right, so we're going to learn what a mole is, we're going to learn what Avogadros number is, and how to use them to work out the number of atoms or ions or things like that in a formula mass unit. Let's go. Right, so individual atoms or molecules are too hard to count, so we weigh them to count them. Because atoms are so small, we're too lazy to say, times 10 to the power of whatever. So we simplify the communications of numbers of atoms by using a word to describe a number of atoms. And that's similar to the idea of how we use the word a dozen to describe the number 12. We use a word, mole, to represent 6.022 times 10 to the 23 particles. All right, so it's just a word to describe that number, 6.022 times 10 to the 23. So instead of having to say, we can say 1.25 moles of oxygen instead of 7.528 times 10 to the power of 23. So that's this word mole. It's a word that represents a number. All right, what number is that? That's 6.022 times 10 to the 23, aka Avogadros number. All right, so this number itself is known as Avogadros number, and then we use it in an equation, which is this one here. N is equal to the number of particles over 6.022 times 10 to the 23, which gets you the first equation of this mole. All right, so first question might be, how many molecules are in 1.6 moles of CH4? So that would be something like, so number of particles is equal to n times 6.022 times 10 to the 23, which would equal to 9.635 times 10 to the 23. All right, particles or molecules in this case. All right, how many atoms are in 4.2 moles of Li? So the number of particles is equal to n times 6.022 times 10 to the 23, which is equal to 4.2 times that, 4.2 times Avogadros number, which would be 2.529 times 10 to the 24, atoms. Right, and then again, we can do this again for 8.7 moles of something. Right, so that's nice and easy. Okay, and hopefully you tried that out yourself just to make sure that you can do it. Make sure that you know how to use the times 10 to the power of whatever button on your calculator. If you're not, come see me and we'll go sort that out. Okay, that's the easy stuff. Let's move on. So we can still use this equation to go start working out the number of moles of stuff, because we were just working out the number of particles, so now we can work out the number of moles. So how many people are there in moles? Right, so you might say N is equal to number of particles over Avogadros number, which will be equal to 7.5 billion. How many zeros there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right, over Avogadros number. Right, nice and easy. 4, 5, 6, 7, 8. Not a lot. 1.245 times 10 to the negative 14. So quite a small number of moles of people on the planet. All right, how many moles are there in 1.6 times 10 to the negative 14 atoms of Na? Not a lot. So 1.64 times 10 to the 14. Okay, that is, I'm not going to write out the equation, but you should practice it yourself and make sure that you get that number. Nice small number. All right, and then finally 5.84 to the 32 divided by Avogadros number is a big number, 9.698 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 moles. Okay, so make sure that you have a go of those and make sure you get the same value that I do. All right, so component ratios, last bit. So the chemical formula of a substance represents the ratio of parts of a compound, and thus represents the ratio of moles of the compound as well. Right, so what does that mean? If I have 1 mole of Na2CO3, notice that the chemical formula says Na2, so there are 2 moles of NAs and 1 mole of CO3s. Okay, so effectively that chemical formula here shows that there are 2 NAs and 1 CO3, so therefore whatever I have here, I have to double for the Na and have the same amount for the CO3. Right, again, 4.7 moles of Ca3PO42 has then 14.1 moles of Ca ions, because that's 4.7 times 3, and 4.7 times 2 moles, which is 9.4 moles of the phosphate ions. Right, so then we have to always remember to take into account the ratio of parts of a compound when answering questions, all right, because it can be a bit tricky. So how many atoms of nitrogen are there in 5.2 moles of Ca bracket NO3 bracket 2? All right, so what this is showing is that there are 2 N's per formula unit of calcium nitrate. All right, so there are 2 N's in it. So therefore, I have to do 5.2 times 2 times Avogadros number, right, which will be equal to 5.2 times 2 times Avogadros number, which will be some value. Let's have a look. How much is that value? 6.26 times 10 to the 24. All right, how many ions are there in 6.3 moles of lithium nitrate? Okay, so this is a bit of a trick question. Give it a look. There's ions in the Li and there are ions in the NO3, which effectively means that there are 2 ions per unit of LiNO3. All right, so 2 ions per unit. So I would have to do 6.3 moles times 2 times Avogadros number, which should be equal to 6.3 times 2 times Avogadros number. Right, 7.59 times 10 to the 24 ions. Okay, you get the idea that there are 2 ions within that formula, so therefore you have to multiply those numbers by 2. All right, and then how many ions are there in 5.4 moles of Al bracket OH3? So again, just trying to say that, okay, I got 1 aluminium ion and then 3 hydroxide ions. Okay, so effectively in total you have 4 ions. So 1 and 3, 4 ions times the 5.4 moles times the Avogadros number. All right, so 5.4 times 4 times Avogadros number will be equal to 1.301 times 10 to the 25 ions. Okay, so it's important to know these component ratios and how they work. All right, making sure that you read the question. What is it asking you? Is it asking you for parts of it? Is it asking you for ions? Is it asking you for molecules? Things like that. Make sure that you have a read of it. All right, that's it. Off you go. See you later.